finally, we're finishing up 1.6, and we're going to mix that with 1.7 since it's all about absolute values. I know probably in high school or whenever you learned just that absolute value was always equal to a positive, but why was that? It's because absolute value represents a distance, and it's a distance from 0 on the number line. Now, if you put 0 on the number line, you see that you have two directions that you can go, right? And we need to think in terms of units. For this first example, if the absolute value of x is equal to 3, that's 3 units from 0. So from 0, we can go forward 3 or we can go backwards 3. And because this is equality, then x is equal exactly -3 or +3. So whatever you have inside the absolute value bars, if you have equality, you're going to set that equal to the plus or minus of this number right here. Now look at example 2. We don't have plain old x in here. So the value of x minus 2, if it's exactly 5 units from 0, we can go forward 5 and put x minus 2 there, or we can go backwards 5 and put x minus 2 there. So we have x minus 2 is either equal to exactly -5 or +5. Solve for x and you get the two values of x that make this a true statement, which is always what you're doing when you're solving an equation, right? You're finding the x values that make it true. So if x equals -3, you plug the -3 in there and you get absolute value of x minus 5, which is 5. You plug in the +7 and you get absolute value of +5 is equal to 5. So you see how that works. So when you're doing absolute value equals, the first thing that you have to do is to isolate the absolute value itself. So we want to get rid of the 4 by adding it and then divide away the 2. We end up with this absolute value equation. So we know the stuff in the parentheses doesn't matter, in the bars, doesn't matter what it is. It either equals the +5 or the -5 because you start at 0 and you go forward that many units and backwards that many units, because the distance of this value from 0 on the number line is exactly 5 units, and there are two directions. So this blob is either exactly -5 or +5. Now just solve each equation separately and you get the two values of x that make this statement true. All right, so that's the way we're doing all of these problems when there's an equal sign. But what happens when you have an inequality instead of equality, a greater than or less than? All right, now for these problems, we have to think in terms of distance. How many units away from 0 is this thing on the number line where it's exactly equal, and then are we in between? Are we closer to 0 or farther away from 0 on the number line? So let's examine. So we're going to examine inequalities now. So if your absolute value, or the distance from 0 on the number line where x lies, is smaller, this is less than is smaller than 4 units. If a distance is smaller, that means we are closer to 0. We're less than 4 units away. So you find the 0, I can go backwards 4 and forward 4. That's good. If my distance is shorter, then I'm closer to 0. That means the -4 and the +4 are my boundaries, and I'm in between because I'm closer to 0. Whatever the x is, it has to be closer to 0 than 4 units, which puts it in between the -4 and the +4. And the way we're going to do that for these problems is to use a compound inequality, because it has to be, x has to be greater. Remember, it always points to the smaller value, right? So this means x is bigger than -4 and smaller than +4 at the same time. Now we're going to use this compound inequality to work the problem and solve for x, and then we're going to convert our answer to interval notation, which I'll explain on the next page. So here, the value of x is closer to 0 than 4 units, which means that x is bigger than the minus and smaller than the plus at the same time. Look at what this looks like on the number line. The value of x lies in between here, in between the plus and the minus. And notice that we have just straight up less than. There's no equal to bar here. So we're not going to include the endpoints. X can't equal -4 or +4. It can get infinitely close, but it's never going to be exactly. So in my interval notation, I have an open parenthesis at each end. And if I graph where the x value is on the number line, I can see that this interval begins at -4, ends at +4, and it does not include the endpoints. And I translate that straight into what's called interval notation. The open parentheses means that it cannot equal the endpoints. If I equal the endpoints, I'm going to box those guys in, which I'll show you in the next example here. So the next example, we have this blob, which has to be smaller than 3 units or exactly 3 units. It's less than or equal to. So I find 0 on the number line. I can go back 3 and forward 3, which puts me in between the -3 and the +3. And that's not where x is, that's where x minus 2 is. So I'm going to use this compound inequality that shows, just like the number line, x minus 2 is in between the minus and the plus. And now I'm going to add 2 to all 3 intervals, and I get plain old x in the middle, and this adjusts the -3 forward to -1. I went forward 2 units. From the 3 here, I go forward 2 units, and I'm at +5. And now x lies between the -1 and the +5, just like on this number line here. Now it's not x minus 2, it's plain old x. I picked this interval up and moved it forward 2 units, and it put me here, and that's where x is. And notice that I have the or equal to bar, which means I'm boxing in the endpoints. So I can equal the -5, and I'm sorry, the -1 and the +5, right? Here's my compound inequality, and this is how it's interpreted as interval notation. And you can steal this straight from the number line if you graph it on the number line. I don't need to see this. I don't need to see this, but you need to use those to get this. This is your answer. And if you're told to put your answer in interval notation, you have to do it to get all the points on the question. Okay? So this shows the interval from -infinity to +infinity where the x value lies on the number line. And the ends are boxed in because you're equaling. Up here, you have an open parentheses because you're not going to equal the endpoints. Okay, both of those examples were less than, which put our final answer in between or closer to 0. But what if we have greater than, the absolute value greater than? Well, that means the distance is, if distance is, greater, then it means farther away. Boy, I cannot spell. Wow. Let me fix this. Farther away from 0 on the number line than however many units. So if the absolute value of x is greater than 3, it's farther away from 0 than 3 units. So I find 0, I go forward 3 and backwards 3, but x is farther away. So I'm going to start at 3 and go that way, start at -3 and go that way. It's farther. Now notice that I can't be in both places at the same time. So I'm going to need two separate inequalities, one where x is less than the negative or greater than the positive. Always say that to yourself. It's less than the negative or greater than the positive. And it's or instead of and, because I can't, and means both at the same time, and I can't be both places at the same time. So I have two separate inequalities with or in the middle, which gives me two separate intervals. And what is this pointing to on the number line? It's pointing to minus infinity. And what is this pointing to? Positive infinity. So my interval starts at minus infinity and stops at -3. And over here it starts at 3 and goes to positive infinity. And I can never equal infinity. So infinities are always open parentheses. And in this case, I didn't have the or equal to bar, so my -3 and my +3 are also open parentheses. Let's try another. Okay, if I have this blob, absolute value, so the distance of this, whatever this value is greater than or exactly equal to 5 units on the number line. So I set up my number line. Here's 0. I go to 5 and to -5, and my blob is farther away. Notice that I have the or equal to, so I box in my endpoints. 5 is the boundary, and I'm farther away than that. So this guy right here gives me this inequality that the blob is smaller than or equal to -5, or it's less than to the left on the number line, or it's to the right or exactly equal to the positive. Less than the negative, greater than the positive, and with an or in the middle because I can't be both places at the same time. And now I have to isolate the x for both of those inequalities. Now remember that if you multiply or divide by a minus, it's going to flip the entire number line, so your inequality symbol will flip. It doesn't happen often, you can avoid it, but if it does, remember you've got to flip, okay? So I'm going to subtract the 1, that leaves me with the 2x, and it makes that a -6, divide away the 2, and I get that my x has to be to the left of -3 or equal on the number line, which gives me minus infinity to -3. Or I subtract the 1 here and get 4, I divide away the 2, and I get to x is greater than or to the right of 2 or exactly equal to. And there is my interval notation answer. So, greater than the positive, less than the negative, isolate the x, pay attention to whether you're equal to or you're not equal to, and that will tell you whether you have a box or an open parenthesis, and remember you can never equal infinity. So to review, if the absolute value is less than, pointing to the left, then you have a compound inequality. Your value of x will lie in between two values. You'll get a single interval. If the absolute value is greater, then you're farther away than the plus and minus, which puts you on the outside of the two boundary values. You get two separate inequalities, which is two separate intervals with an or in between. Now, some of you in high school use the union, and this would be an intersection because it's an and. I'm not going to ask you to do that. You're getting a single interval here, so you don't need to say this interval and that interval. I want you to show that it's in between the two endpoints. And you can use the union if you want. You can write or if you want, or you can just list the intervals that are in your solution. And lastly, remember, if you multiply or divide by a minus, you have to flip the inequality sign. You won't see that very often, so I'm not going to bother to write that out here. and this is the very last piece of 1.6. Boy, 1.6 was full of stuff, wasn't it? And this is just the equal signs, and this is your inequalities. Every other odd means every fourth problem. It looks like a lot of problems. It isn't really. The beginning of 1.7, you're just doing inequalities themselves and writing your answer in interval notation. So, and then the second half of this will introduce the absolute value stuff. So every fourth problem, make sure that you get it. That's all I care about. Make sure that you understand it. Always check your answers in the back of the book before you move forward with the next problem.